Hello all, welcome to another episode of AWS Show and Tell. I'm your host Anil Nadvinti. I'm joining you here from New Jersey. It's great weather here today. I saw 100 degrees showing on my weather panel, and we're also having a great topic today, right? So uh, this is an exciting topic. We have a number of demos. It's on model. Maybe I should just go through the introductions first and then talk about right. Again, a little bit of introduction myself. You see me in the show previously. I support enterprise customers in the fintech space, and joining along with us are our specialists on SageMaker AI. Shushmita.
Thank you, Anil. Hello, folks. My name is Susmita Marupaka. I lead the product marketing for SageMaker AI Inference. I'm joining from sunny California and I've spent a lot of time with AWS. Just kidding, a little over a year. I'm excited to be here.
Thanks.
I can go next. I'm Mary Hasko. I'm a principal Gen AI specialist. I focus on SageMaker, previously focused on a kind of end-to-end developer, now focused on SageMaker Inference. And I'm reporting live from very hot New York City and hopefully a little cooler than New Jersey, but still.
Awesome. Yeah. Thank you, Anil, for having us. I'm super excited to be in our first show and tell covering SageMaker AI. This is Vivek. I'm the worldwide lead architect for SageMaker Inference. And I'm super excited to talk to you all about some of the amazing features we have been working on and how they will benefit you. Based in California, the weather is always good. Can't complain about California. Super excited to be here.
Excellent, right? So we have East Coast and West Coast joining today, and we have folks from all over the world who are joining us. Let us know where you're joining from, folks. As we get into the topic, right? So again, we have the SageMaker specialist team joining us today, but let's talk a little bit about what's happening, right? So we're all talking about training and being able to fine tune the models, and training gets all the glory, right? So that but inference is where the magic really happens, and that's where the model is actually delivering the value. And in today's episode, we are going to talk about SageMaker AI Inference. This is the last mile, if you may want to call, from where the trained model is delivering value in production. And our colleagues here are going to demo and talk about SageMaker AI and walk through some of those recent launches to enable you to deploy the models at scale. We'll have, again, they'll show you how to turn that weeks of benchmarking effort into hours, right? So, but as we get started, maybe a quick poll for you, right? So, how many of you are familiar with SageMaker AI, and are you using this, right? So, let us know. But as we get started, maybe as the poll comes through, Vivek and Shushmita, maybe just kick it off.
Yeah, so I'll start presenting here in a bit, but to just give some background, right? Like where is SageMaker in the AWS portfolio of services? So in AWS, we have two flagship AI ML services, one being Bedrock, the other being SageMaker. Bedrock is an inference platform where if you want to access models through APIs like Claude, Nova models, you can access them through Bedrock. You can also access some open source models from there. But SageMaker, on the other hand, is the platform if you want to customize the models and you want to do a server-based deployment. Say if you want to fine-tune the model, or if you want to quantize the model and you want to deploy them on dedicated GPUs. And be able to control what container you want to use, what type of serving framework, what scripts you want to use. So you get more control, and at the same time, you get to choose how you want to deploy and how you want to configure and so on. So that is to set the context on SageMaker AI. Sushmita, you want to add anything to that?
I could just add some things as well. And so from like the inference side, especially when you're building like agentic flows, you might just want to call kind of an open source model or even closed source, just an API, and Bedrock is really good for that. However, as customers start to scale, they start to kind of see that there's a need for maybe kind of optimizing on latency or optimizing on cost for different use cases, in which case having more granular control of their container, how they serve these container stacks to their customers for inference, how it flows within their entire flows, either agentic or a chatbot or whatever that may be for the inference, they might want to have a little bit more control. And SageMaker AI, SageMaker dedicated endpoints are a really good place for that. It also means that you can kind of control the exact GPUs that you want, and also you can kind of fine tune either throughput or latency or cost. So you really get the exact right inference that you need for your use case. And if you have regulatory requirements like data sovereignty, things like that, it really helps to have kind of a more of a dedicated endpoint versus just an API call.
Awesome.
All right, so I think today we're going to dive deep on SageMaker Inference. We're going to do some demos like Anil said in the beginning, so we'll cover that. But we definitely want to kind of have a just overview of what SageMaker Inference is and why you would need that, and kind of inference in general. So SageMaker AI as a whole is kind of a big term for a lot of different services that allow you to have end-to-end machine learning and Gen AI on AWS. So you can start with your open source model, and you can kind of choose from a model hub that we have. We'll demo how you can easily deploy that in one click. But if you want to fine tune it, you also can fine tune it on SageMaker. So you can do distributed training and have hundreds, thousands of nodes, or you can just say, hey, I have a data set, I want to fine tune that. You can use different types of fine tuning, like reinforcement learning, supervised training, and you can just have it all just in a UX format. So you have kind of an end-to-end going from your data set to fine-tuning it to all the way to deploying it and covering that within an MLOps and governance. So it's really end-to-end, and you can kind of pick and choose what you want to do. But today we're going to focus primarily on inference.
Yeah, and just to add to that, right? So we have a lot of offerings here, but one of the good things in SageMaker is it's a very modular approach. So you can pick and choose. If you just want to do experimentation, you can do experimentation. If you want to train, bring a trained model and host it on SageMaker, you could do that as well. You can just train on SageMaker. So you don't have to use all of these features. You can just pick and choose, what you want to do, and grow from there.
So now, Vivek, again, we keep seeing the models available in Hugging Face, right? So can you bring those models into SageMaker? Again, there's a lot of open source models that are available. Can you fine tune any model out there that that we can find? Maybe like if you pick Llama models, right? Can we bring it to SageMaker AI and maybe fine tune it?
Yeah, absolutely. So since this is a platform where you can customize the entire stack, right? You can bring your own container, you can bring your own scripts, you can bring your own model. So basically anything that is out there in Hugging Face, you can directly point it to it and deploy it. I have examples that I'll show in the demo, but yeah, it's as simple as that. There's no restriction.
And we know that when we started, we said, we can train the models, right? So can we train models from scratch as well?
Yeah, so there in SageMaker, there is two offerings for training, similar to Inference. There is two offerings as well, which Susmita will cover. So within SageMaker, there is training jobs, and then there is HyperPod. HyperPod is our approach if you want to do large scale training. So think of like building foundational model from scratch, which takes hundreds of GPUs, and training runs over several weeks. And there you need resiliency, you want a way to do checkpointing, you want a way to do observability. So that is a good platform there. But if you want to do like quick fine tuning, like you say you have labeled data sets and you want to do supervised fine tuning, or you want to do reinforcement learning fine tuning. For that, we have SageMaker training jobs where you can kickstart a training job with a script and bring like your data set, and then SageMaker will take care of training, and then it will save the model in S3. And then you can also have a pipeline where once the model is saved, you can then deploy it to SageMaker endpoint and access it. So yeah, have that end-to-end pipeline there.
Thanks. Yeah, so this is what we're going to break it down for you along with the inference, right? So yeah, go take it away.
Yeah, just one thing to note on that. What's really nice about SageMaker is it's not just Gen AI and LLMs, and we'll definitely dive in that. But if you want to do predictive ML, which is XGBoost, which we still hear is very popular amongst companies, you can definitely still do that as well and kind of train your own models. On the Gen AI side, it's a really good place, and a lot of our roadmap and kind of what we're working on is to support all these customers that are doing inference on Gen AI and have been on SageMaker for many years. And one thing that's nice kind of with the model hub that we have, which is called JumpStart, and we'll showcase that, is we're constantly adding new models. So if you want Quen or DeepSeek or multi-models like Gemma, we're kind of continually adding those so you can deploy them and work in your application right away, or you can fine tune those as well. So it's really nice because you have a lot of different options, which can get a little confusing at times. There's a lot of information and different services that we have, but it also means that you can kind of have your end-to-end there. And if you want to kind of fine tune your data sets and pre-process them, you can do that. But we're trying to kind of always keep on edge of the latest open source models that are coming out, so that you don't need to always kind of build from scratch. You have those models handy. And it also means that you can kind of compare them. And that's what Vivek will demo today, is you can be able to say, okay, I have a model. What does that look like on inference in terms of having it be the most optimized for my use case? We'll definitely do that, because a lot of customers that we're seeing and users are struggling of kind of, okay, which open source model do I use? And then once I have selected it, maybe I fine tuned it on my own use case. How do I make sure that the inference is where it should be, that I'm not provisioning too large of a GPU, or my latency needs to be super low, and therefore how do I kind of optimize for that? And so we'll kind of show that, but it's nice because you have that full end-to-end, and you can have doing predictive ML, but also obviously, and kind of where a lot of our users are focusing on is Gen AI.
Yeah, absolutely. All right, so we want to get into the slide, Sushmita.
Yes. So till now we have discussed about SageMaker, but let's start from the customer's point of view. When we speak to our customers are saying these three things. First, today the models have like tens of billions of parameters, and they have to optimize on instance type, compilation, and quantization techniques. And also there are multiple models in production, which exacerbates the complexity. Second, when it comes to cost, to manage or not is the question. When the customers choose DIY approach, it is on the lower end of the cost spectrum, but it's going to spiral the operational burden of managing the infrastructure tools rather than deploying the models. Not only that, as Vivek and Mayer mentioned, benchmarking for the right model, choosing on instance types, testing, retrying, and configuration takes weeks of efforts. And last but not the least, customers are optimizing on various parameters based on their requirements and use cases. For some customers, latency is important, time to first token is important. For others, throughput and max concurrent sessions are important. So if you look, it is a wide spectrum out there. I have a question for you. What are you optimizing for when you are deploying your models?
Right, it's always a question of which two do we pick, right? So either the performance and cost, or complexity, right? So I think cost and complexity. I think that's kind of where we all end up.
And the ideal choice is not one, right? It should always be a trade-off between all of this, because if you go for the absolute best performance, it could be like 3x more cost, right? So it has to be in the middle where you meet your SLAs, simple to deploy, and at the same time costs are in check. And that is where we have our features, which we will dive into to help you figure out what is the right balance.
Yes, when it comes to SageMaker Inference, as Vivek and Anil mentioned, we have covered all bases. When it comes to time to value, you'll really see the demo live on how quickly the endpoints come up, how efficiently you can finish your benchmarking by eliminating manual retries and weeks of efforts. Not only that, as Mayor mentioned, it gives control at container level. Bring your own model, bring your own custom container. If you have custom architectures that you want to standardize on, bring it on. Last but not the least, the built-in monitoring for data drift, model quality, bias, etc. It's all covered. Whether you're using generative AI models or traditional ML or classical ML model, SageMaker AI Inference covers all bases for you to ensure you do not have to have binary choices when deploying your models in production. All right, we discussed what are the challenges and what SageMaker AI Inference has to offer. Now let's understand what paths you have. So when it comes to AWS, we meet customers where they are in their journey. If you are an EKS customer standardized on Kubernetes, SageMaker AI Inference offers HyperPod Inference with standardized EKS clusters with built-in operational re- with built-in operational readiness which is available to you, which will drive your time to market. For example, if you are in standardized on Kubernetes, you don't have to worry about deploying multiple operators. Instead, SageMaker HyperPod, the single operator, will help you alleviate and increase your time to value. Next up, if you are a customer who are looking for dedicated endpoints to deploy your models with container level configuration and control, and you have some specific open source models that you want to optimize on, or if you want to have more control and granularity over your custom containers, serving frameworks, SageMaker Managed Inference covers that basis as well. So, in a nutshell, we have two choices. If you have standardized on EKS, SageMaker HyperPod Inference is for you. Or else, if you want to deploy your inference models behind dedicated endpoints, SageMaker Managed Inference is your friend. Now, Vivek will showcase how you can achieve your time to value with both of them and add few points additional on how SageMaker AI Inference helps you in your deployment journey.
Yeah, thank you, Sushmita, for that overview. So this is one quite common question that we get is customers often ask us which one to go with. There's you're saying two offerings, so which one do I select? So it's simple, right? If you are a Kubernetes shop, you have expertise in Kubernetes, and you want lower level control, like you want to bring in your own framework that you're familiar with, HyperPod is a better option there. But if you want a managed experience, you have a team of data scientists, ML engineers. You don't want to get into like VPCs, subnets, security groups, Terraform, all of this. Then managed inference will abstract away all of that and just give you an endpoint where you can start accessing the model. Right. So
Now,
it depends on
now
how
when
you want to access it.
now regardless of which method we pick here, right? So with which approach we pick, the end result model, right? So is that going to be similar? Like, because folks might be wondering, right, which option could lead to what at the end state, right, over here. So maybe if you want to speak about that.
Yeah, so model is deployed in both these offerings. It is just that in the second one, it is deployed on a Kubernetes cluster. So you access it via a load balancer and a pod running in a Kubernetes cluster. Whereas in managed inference, it is deployed on a SageMaker platform. So your entry point will be the SageMaker managed load balancer, and you will use the AWS like SDK, SageMaker Python SDK, or CLI Boto 3 to invoke the model.
Mhm.
So it's just two different ways of accessing it. But yeah, using both, you can probably deploy both similar models, fine tune, customized. You have flexibility there. So it's just like depending on what comfort level the customer is and their expertise lies with.
And you can kind of think of it like on a spectrum. Bedrock is the most managed. Then you have SageMaker Managed dedicated endpoints inference, and then you have HyperPod, and then if you want to EKS. So it just depends on where you want to be on the managed scale.
Yeah, exactly. But the rest of the session, we will focus on managed inference. And so when we talk about serverful deployments for customers who are not familiar, they get frightened, right? Because you have to learn a lot of things across the stack, like how do you provision GPUs, CUDA drivers, how do you set up networking, how do you do the right routing, how do you do load balancing, observability. So there are a lot of components that you have to figure out when you set up a platform to run inference. But what SageMaker Managed Inference does it abstracts away all of it, right? So all you have to do is you create an endpoint configuration, which is step one. And in this endpoint configuration, you provide what type of model you want to deploy from. This could be a Hugging Face model, to your point, Anil. Any Hugging Face model ID, you can add it there. It could be a fine-tuned model that is located in S3 bucket. It could also be in a model registry that is part of also the SageMaker platform. And then you provide which container you want to deploy. Again, you have full flexibility here. One of the popular ones is VLLM, which a lot of customers use. SGLang is another one. TRTLM from NVIDIA is another one. So depending on which one works for you, you can set that as well, and which instance type you need. H100, H200, B200s. We have a wide variety of options. You can select which node you want to deploy on, and then yeah, that's it. Deploy the model, and once you deploy it, the deployment is successful. Step three is you start invoking the model. That's it. You don't have to worry about anything else beyond these high level configuration. You can set up policies like what do you want to auto scale on, what do you want to load balance on, these kind of things. But all of those are just API level specs. You don't have to go to like AWS console and wire all these different things up. The Uber point is that we are making it simple to deploy, and at the same time we are also giving you a lot of flexibility. So you have instance choices, auto scale on different parameters. You can hook your CloudWatch metrics to your auto scaling capabilities and scale the number of GPUs, because inference is not a constant thing, right? It will scale up and down based on demand. During daytime it will be much higher, during nighttime it will be lower. So you want to be able to scale to save costs. So that is already built in. Observability, when it comes to GenAI inference, the metrics that you want to look at are different. Beyond just CPU memory utilization, you have to look at what is the GPU utilization look like, what is the error rate, what is the throttling issues you have, all of these capabilities. And then multimodal is a big thing. So we have been seeing a lot of customers use SageMaker for multimodal capabilities like voice AI, image generation, even short video generations. So all of these models, there's a lot of innovation happening in these models, and SageMaker, you can deploy any of these models. We also have a lot of examples showing different modalities, which I'll walk you through, but those are supported. Streaming as well. So when you're doing like voice real-time transcription, you want streaming both ways, you streaming the input and then getting the response back. That is also inbuilt. So we have built all these capabilities so that you don't have to go and figure out how to build it. You just come here, set it up, configure what you want, and then just go deploy it. Yeah, any questions or inputs, Anil, or anyone?
Hopefully we'll see some of this in action, right? So
yeah, absolutely. Yeah, so with that setting the context, I don't want to spend a lot of time in talking through the slides. I know you all are waiting for demos, so I just have two or three more slides. So we've launched features recently to address common pain points from customers, right? So we know that GPUs are expensive and they are constrained, right? So we've built a capability where you can come in, you can define what model you want, what traffic pattern you have, and SageMaker will run pretty thorough benchmarking, optimizations for the model based on the traffic pattern, and give you a recommended deployment path where you can deploy, which will give you the optimized result you're looking for. If you go back to the slide which Sushmita was mentioning, you have three levers: throughput, latency, and cost. So customers can come here, they can select what they want to optimize on. Like if say throughput, then SageMaker will run a benchmarking and recommendation job to maximize the throughput and give you a recommendation to deploy. Basically, the whole idea behind this feature is, instead of taking days and weeks and a lot of time to do different permutations and combinations to identify the right match, you could just do yourself in a self-service fashion, right? So this is the feature that I'll demo. And how this works at a high level is you bring your model artifacts, and then you define your traffic patterns, and then allow SageMaker to do the job. You review the results, which are in an HTML format and detailed benchmarking numbers, and then you take that to deploy. With that, I'll switch over to uh, sharing my uh, yeah, code samples.
So while Vivek is bringing up his demo, I just wanted to call out one thing. Everything is a simple three-step process when it comes to deploying models in SageMaker AI, and you will see how cool it is.
Yeah. All right. So you all can see my screen, right?
Yeah.
Okay. So I'm in the SageMaker console. I think Anil, I missed how many folks have tried SageMaker. Did you get a response there?
We did not get the response yet, but I think
Okay.
let's, yeah.
Okay. So I'll just yeah. So this is a SageMaker console. There's a lot going on here, but it's simple. Like you can just focus on what features you want to use. In this case, we have deployments here, endpoints. This is where all of our deployments will show up, and then you can click on each one and um, go deeper into what details you want to know. We also have SageMaker Studio, which I've opened here. And this is like an IDE, which gives you access to the endpoints, JumpStart, which is our model hub, your pipelines, and Jupyter notebooks if you want to open a Studio IDE notebook and play around. So this is like a neat one-stop shop for all of these different things.
Can you show us what models are,
Yeah,
possible in the Jumpstart?
yeah, I was about to go there. So we have a big laundry list of models here. You have different filters to act on. Like we also have the latest ones available. Like Gemma 4 was just launched recently, so we have that Gemma. We also have like the big models like Kimi K2.5, and it's you can come here, you can deploy them directly with a click of a button. Some models also have the option to train. This model particularly does not have option to train, but you can select another model here, say like Quen. Right, so here you have the option to customize, and there is like multiple options to customize with the UI or with the code, and then once you customize you can deploy that as well. So yeah, we also have like Black Forest Flux models. These are image generation models. Even these you can deploy, and when you deploy through these, you don't even have to select what container, what environment variables. Everything is packaged. You just click a button and it'll be ready for you. So let's go and do a quick deployment of GPT-OSS 20B model. This is from OpenAI, one of the popular ones. You click here, deploy, and then you can select the instance type you want. You can select minimum, maximum, and then just click deploy, and it will go and deploy. I already have an endpoint. This will take like 7 to 8 minutes. So I have an endpoint that is already deployed yesterday. This is a Quen 3.6. So when you deploy the model, it will be like this. It will show you in status service. It will have logs showing up. There is also a playground here where you can interact with the model and see the request responses. So this is displaying real-time request response. But when you deploy the model, you want to be able to use it in your web apps, right? Like a Lambda functions or your containers where your actual application is running, which could be an agentic workflow, chatbot, whatever it is. So in that use case, you can use the endpoint and use that in your code to start invoking the model. Like for example, this is the name of the endpoint, right? So I can take this endpoint. I can I'm going to this Jupyter notebook, and I am just adding that as an entry point here. um, Sorry, one second. Yeah, So endpoint name. So this is a notebook, but this code could run anywhere. And then I'm just initializing the SageMaker Python SDK, in creating a predictor here, and then just started invoking the model, asking any prompt. Um, it will generate the text, and when it generates the response, it is invoking the model. Again, this could be a RAG workflow, a Lambda, a chatbot, um, anything. Yeah, so this is how simple it is. You deploy the model, and once you deploy, take the endpoint name and use it with the SageMaker or Boto 3 SDK anywhere. So that
So
is
now
the easiest
one
way to deploy.
one follow-up question, Vivek. When we use the models, with some of these models, for example, Quen 3
Mhm.
point 5, like it supports OpenAI compatible
Mhm.
endpoints, right? So
Yeah.
I see that we have the SageMaker configuration here, but
Yeah.
if you want to use that endpoint, like how do we configure in applications that already support the OpenAI format?
Yeah, so right now there is a a small adaptation that you have to do. If you're using something like Light LLM,
Mhm.
it already has code to use SageMaker SDK. If you're using Strands, for example, it can adapt. Backend has code to support SageMaker endpoints. But if you are writing your own code, yeah, you have to do some slight modification to be able to use the SageMaker.
So you just create a wrapper and then you use the
Yeah,
wrapper if
yeah,
you're doing that,
absolutely.
right? Okay,
Yeah,
perfect.
that is for now. Yep. Okay, so this is an easiest way. Now you can also deploy it by taking a, I'll switch my tab here to show the another feature that I was talking about earlier, which is a recommendation and deployment. um, okay, before that, I'll go to this examples. So this is the repository that has a lot of deployment examples with customized containers, configurations, auto scaling, observability, and all of that. So jumpstart, think of jumpstart as an easy way to deploy, but in reality, when you're going into production, you want to be able to customize a lot of things before you deploy. So that is where here we have examples such as models. You want to deploy different models, you can select here, go through which model you want to deploy, and there each one has like a notebook to deploy. Like DeepSeek V4 came out 2 weeks ago, you can access here, take this notebook and clone it, and then just use it to deploy. So you're using the model ID from Hugging Face like this, set the instance type you want to deploy, and then select which container you want to use. We have our managed containers, so you can use like the container from AWS repository, and then actually let me zoom this a little bit. Yeah, set environment variables as you see fit, and then do a deploy, create model, and then do the deployment. We have this capacity reservation. So if you want to deploy on like H100s or H200s, it's hard to get them on demand. So you can reserve nodes for like 6 hours, 1 day, any number of days until like 6 months, and use that reservation here to deploy the model onto it. So this way you don't get run into capacity issues when you do a deployment. Okay.
Especially with the GPUs,
Yeah,
being
GPUs.
so on.
We all know the challenges of getting GPUs. So we are making it easy. Also, this is also self-serve. You don't need to create tickets and wait for AWS teams to approve it. It's just like self-serve. You once you create a capacity reservation, you just add it here and start using it.
And
Right?
then we'll follow up on the next demo towards the end if we have time. Will also be how you can do kind of capacity aware routing. So if you're not able to get the compute that you need, you can say, okay, I want to default to the next GPU and maybe a cheaper one or a slower
Mhm.
one, and you'll be able to do that. So we're trying to make it as easy as possible to make sure that you have the capacity you need to run your use cases.
That's a
Yeah.
great call
Yeah.
out there.
Yeah. We'll get into that. Hopefully try have time for that. So again, some of the audience will probably be familiar with these names. These are the most popular like serving engines. So we have examples for this under engines. We have a lot of features from SageMaker. So I'm going to show the bidirectional, the GenAI inference recommendation in the next demo, and then the capacity aware instance pool. These are the new features. I'll be demoing that, but all of our features and the new ones that we'll be adding, we will continue to add here. So bookmark this link, and come visit here, play around with these whenever you get a chance. So going back to the demo for recommendation, right? So this is how the code looks like. The starting is similar. You just load the Boto 3.
So Vivek, I
Yeah.
want to quickly interrupt you. So what is this recommendation demo, right? So what is it doing?
Yeah. So when you deploy a model, you say you want to deploy a Gemma 4 model on an endpoint. uh, you can deploy on a single node. It works fine. You invoke it, you get responses, it works fine. But if you are taking a model from POC to production, it is extremely hard to determine how many GPUs you need, how many model copies you need, and how many number of requests each copy can handle. And because you also have to maintain the SLA, right? We all hate when you send a request to a chatbot and it keeps spinning, right? You need to have the right SLAs. So this one will help you with that. Instead of playing around figuring it out over several weeks, you just come here, you follow these steps, and then it will do for you. And I'll show you how the report looks like. So it'll give you a detailed report on how to actually.
And maybe like one more follow up is sometimes we ask for more tokens per second, right? So
Yeah.
how do we control or make that better, right? Is
Yeah.
that something that we
Exactly. I think you are getting to the right point, and I have that answer for you right
there
here.
you go. All right.
Okay. So in terms of configuration, right? So this, let's take this scenario. I want to
Do you want to
deploy
zoom
a
this one
GPT.
a
Yeah.
little bit? Yeah, more. Yep.
All right.
That
Is it good?
works. Yep.
Okay. So let's take this scenario. I am satisfied with the GPT OSS 20B model. It's in Hugging Face. Now I wanna deploy onto SageMaker, and I want to maximize the number of tokens per second. So basically, it's throughput. Increasing the throughput will give you more number of tokens per second. And if you get more tokens per second, it basically reduces your overall cost because you're serving more requests with the same number of GPUs. So you first download the model from Hugging Face. You then push it to an S3 repository. Then you create a AI workload config. So in order to give you the recommendation on what instances, what configuration you have to deploy with, you have to first benchmark it thoroughly. And AI Perf is one of the popular benchmarking tool from NVIDIA. And we have built a managed service using this benchmarking tool. So basically, you come in here, you provide your traffic patterns. So say in my case, I'm expecting 64 concurrent requests to hit at the same time. And I have input requests of 3,500, output of 200, and then I wanted streaming. So you basically configure what you want, what your ideal traffic pattern will look like. Then you will provide a data set to benchmark. This could be my own data set that I have, or if we don't have anything, SageMaker by default chooses an open source data set as well. So this is optional. And once you configure this using this config, you then submit a recommendation job with throughput as the key metric. Here again, you can select throughput, latency, or cost. So when I say throughput, it will benchmark in such a way that it maximizes the number of tokens. Okay. So here I'm providing the model which I downloaded from Hugging Face, providing a URL where my benchmarking reports should be stored so that I can access it, and then providing the instance to benchmark. Again, this instance might not be available on demand, so we ask to do like a small, like 1 day, 2 day capacity reservation and use it. And then, yeah, just trigger the benchmarking. trigger the benchmarking, and then this one will poll until it is completed. And once it's completed, this one will take anywhere from 30 minutes to a couple of hours, depending on the model type, depending on different configuration. And it will now that we've selected throughput as the metric to optimize on, it will run speculative decoding. Right? So speculative decoding is an optimization technique to maximize the throughput. So basically, in LLMs, token generation is an auto-regressive process, meaning that one token is generated at a time, and every time a token is generated, it will calculate the KV scores with that token and rest of the KV cache, and then generate another token, do a calculation. So it's like a slow process. So speculative decoding will speed that up by parallelizing the token generation with these lightweight eagle heads. And instead of generating one token at a time, these eagle heads generate like 3 4 tokens, and the actual model will just supervise it and then just approve reject tokens based on the accuracy. So net is, if you use this technique, you can get up to anywhere from 1.5x to 2x performance benefit. Right, so that is what SageMaker is doing here. As soon as you kickstart this, it will run this speculative decoding optimization job. It will then benchmark it and save the report for you to evaluate and deploy it.
Yeah, and that's just one option. Speculative coding, you might hear it as like draft models, and then kind of with the main model. But you also, there's like kernel tuning. This feature has a lot of different parameters that would take a very, very long time with so many different options. That's just kind of automated for you. But speculative decoding is a key one for throughput.
Yeah, exactly. And for latency, the kernel tuning plays a big role, because when you want to reduce the latency, the kernels need to be optimized. Kernels are the programs that run on the GPUs for the model execution. That is where it is. So here is like how it will benchmark and give you all these values. But it also, I'm just going to the S3 bucket where the report is being pushed to. And if I click open, right, so this is what it generated after running that benchmarking job. So it gave the baseline testing and a train testing. Eagle is speculative decoding. That is one of the technique to do speculative decoding. So as you can see here, with and without, there is a significant throughput improvement. So basically what this means is, if I generate 100 tokens with base deployment, with this optimization, I'm generating 170 tokens. So 70 tokens are added there. So if you're doing that at scale, at millions of request scale, that is significant, right? So that is where optimizing for throughput is pretty significant. And this report gives you this like pretty detailed benchmarking and recommendation report.
So, and then you said that this process could take how long again?
So if the model is small, it can take anywhere from 30 minutes to a few hours, depending on what are you benchmarking against, throughput or latency, like what is the different configurations, the token sizes and all of this. Yeah. So I mean, if generally we work with customers to give them an estimate based on what requirements, what model they have, and we'll be happy to support if the audience have a need to use this. Okay. So so this is the benchmarking service and recommendation that we recently launched in SageMaker. So I'll quickly switch over to the back to the presentation to talk about another feature we have.
So while that's coming up, just a question is, I think when you talk about benchmarks, right? So we see terminal bench, browser comp, MMMLU, right? So these are different benchmarkings, right? So can we run any specific benchmarking by supplying the input? Is that how things work?
Yeah, so there is two types of benchmarking, right? One is to benchmark the accuracy of the model, like if you have a new model, how does that compare with existing models? And then there is another type of benchmark, which is benchmarking for the the response speed, response, throughput, number of tokens for a model. So
Hmm.
this benchmarking that we are talking about is for the second one, right? The MMLU, those are the benchmarking which is out of this context. It is external, using other ways. So yeah, this is more about uh, the performance of a model in real time.
Hmm.
Uh, okay. All right. Oops. Okay. Let me go back here. Okay. Okay. So we went through the recommendation. The other key challenge that a lot of customers have been facing is the GPU constraints. So when you try to deploy a model, if a GPU is available, this could happen when you're deploying the model or when you're scaling up from, say, one node to two nodes. So when you are deploying a model, if a GPU is available, SageMaker will provision the GPU. You will get to start using it. But if there is an issue with availability, it will just fail, right? And then you have to again try with another GPU instance type, do all of it over again, or create a support ticket and try to get a reservation and things like that. So this has been a common challenge for our customers, and they've asked us to make it easy. And so we've launched this capability called capacity aware inference. And this launch just happened like last month, a few weeks ago. And this will make it really easy for customers who want to deploy and scale with GPUs that are constrained, because you can configure multiple GPU options. So say you have uh, a model that can run on G type instances. So instead of just providing a G5 X large to deploy, you can provide three options: G5 X large, G5 12X large, G6 X large. So if you're configuring multiple GPU options, it increases your ability to get a GPU and scale up without running into capacity issues. So that is what we've launched. And the way this works is with the spec that you have, you configure different instance types and set the priority. It's also important to set the priority because you want your best performing instance at the top, and if you don't get it, then go to the second best, third best, things like that, right? So you
Yeah, or you
configure.
might say,
Yeah.
I want a cheaper instance to start, but if that's not available, give me a larger one that's maybe a little more expensive that might be available. And so again, you're kind of optimizing on cost, throughput, like performance and cost is like a huge consideration. So this also helps with that use case. It's not just, hey, I want to kind of scale down to a smaller instance that might take a little longer for my end user. It might also be, hey, I want cost as well.
And also, the best part here is that either you can define your prioritized instances or you specify what you're optimizing on, and the SageMaker GenAI recommendations will provide that instance list, which can be used for scale up, scale down, and can be on it.
Yeah. Yeah. And then the good part about this is also that you can also define different configurations for each. Like, for example, some GPUs will have some nodes will have 8 GPUs, some nodes will have 1 GPU. So the way you deploy across different GPU instances will also differ, and you can configure like different configuration model artifact for each GPU, and then yeah, just deploy, and SageMaker will take care of each one. And it will also provide observability for different GPU types, and you can scale up individual GPUs based on the traffic pattern for each of these GPUs.
Hmm.
So yeah, a lot of modularity is there to be able to not just deploy, um, but scaling as well. Okay. And then I'll switch over to the demo once again.
Yeah, sure. We have about 10 minutes, so that's it'll be really exciting if we can get to the
Yeah,
last demo as well, right? So
yeah. So let me share the screen.
Yeah, and just on the capacity side, that's obviously for users who have these, they're working on these that are needing kind of very powerful GPUs. Capacity, we always try to make it, as available as possible, but it is constrained in some areas, and so there's a lot of different ways that you can get capacity, and this is one where if you set it up, you don't really have to think about it as much versus having to kind of reserve or wait and see. It's enabled once you kind of launch this, and then the auto scaling, like Vivek mentioned, just kind of is handled. So it'll auto scale as your endpoint auto scales. It'll pick up the GPUs it needs based on your prioritization.
And when you're done with that, does it actually also scale, scale in, or how does that work?
Yeah.
Yep, it will scale in as well. You can set up some timeout value, so it will check for 10 minutes if it is still receiving the preset amount of traffic. Say, for example, if you set it to scale up when it exceeds 70% of queues in the request in the queue, and it will scale up, then it will constantly keep checking that number of requests. If it falls below threshold after a time period, it will scale back down again.
And you can set the auto scaling how you want as a user. So that's the value of kind of an endpoint, is it'll scale up and scale down based on the parameters that you decide. And also, as a side note, you may see the term ICE as insufficient capacity error.
Mm-hmm.
Okay, so we have short on time, so I'll just point you to the actual code that has this configuration. So here it is. Rest of it is similar to the previous one. You provide your model ID, your container, all of that. But when you're deploying this capacity pools, you select, like, instead of having one instance type, you select like multiple instance type, and you select priority here as we've discussed, and you provide a routing strategy. So least outstanding request is our preferred routing strategy. So what this does is, when you have like 3 nodes, it will keep track of how many requests are being sent to each node, and send the following request to the node that has least outstanding requests, right? So this will make optimal utilization of the GPUs. So yeah, this is how you configure it, and you start with one if you want, or you can have multiple, and then once you deploy it, you can you can then set up an auto scaling policies there. Like here I've deployed it, and then I just invoke the model here. It's Yeah, I invoke the model here. It's generating a response. It's a pretty big request, so it's generating a response. But you can set up your auto scaling policies once you have here, and oops. It's a blank screen. Okay, I have the response here, but let me. Yeah, so here is how you're setting the auto scaling. You can set auto scaling based on number of concurrent requests. Like here I have 3 nodes, and if I have more than 12 requests hitting the G5X large, scale up, right? Similarly, if I have more than 16 for this one, it's a bigger GPU, use scale up. So that way you can set up scaling up based on concurrency. And then you can also I'll just scroll down. Sorry for the back and forth. I just want to show the key metric. Yeah, you can also have your CloudWatch metrics set that will monitor the concurrent request for each GPU, and yeah, report and scale up and scale down.
Mm-hmm.
Okay, and you can also go to the CloudWatch dashboard and get a detailed view of how the utilization is, and so on. Yeah, I know we just have 5 more minutes. I think if you have any questions in the chat, we can go through them. Yeah.
So I just want to say one thing over here. So SageMaker Generative AI recommendations helps you reduce your weeks of benchmarking efforts into minutes, as you just saw. And with capacity-aware inference, you don't have to retry on ICE errors, or if the instance doesn't come back, it's all covered for you. You don't have to wait on anything. Get your deployments faster using SageMaker AI inferencing.
Great. So, yeah, thanks for coming onto the show today and showing us some details on how this inference can be, how we can use inference from SageMaker AI. I know that's the most important part. Once you get your model, when all these new models are coming up, for example,
Yeah.
DeepSeek version 4 that just was announced, right? So as soon as they're available, people
Yeah.
want to start using them in their workflows.
Yeah,
And
day zeros. I mean, a lot of requests we get in is on the same day. Customers are super excited to try it out because next day another model will probably come, right? So they can't wait for a week to wait for a model. So that's where getting any container, any model from Hugging Face is of key value proposition we have.
So if you want to summarize, like all the steps that you did today, right? So you have a new model announcement, and then they say that the model is in Hugging Face. From that point, maybe if you want to just give like, I know you showed a lot today, but
Yeah.
a mental model of how this all flows.
Yeah, so pretty simple. Like I've you already shared Anil the link for the
I
GitHub
did.
repo. It has like 40, 50 models. It's simple notebook with like 20 lines of code. You initialize your SDK Boto 3. You select which model Hugging Face model ID you want to deploy, which container you have, and there's a lot of examples. Just you take that notebook, go to SageMaker Studio, or you can also run it from locally. Just deploy it. That's it. It's as easy as that.
And then the model, set the capacity reservations or
Yeah, so
capacity.
that's another thing. If you require like a G5 instance that is abundantly available, you don't need any reservation. But if
Mhm.
you deploy a big model like Kimi K2.5 Minimax, which is like 1 trillion, then you need a much bigger instance. Then you have to go through a flexible training plan. I can type it here, but that is also available in the SageMaker console. You can go there, select which instance type you need, and then request that capacity for an n number of days, then use that capacity to then deploy the model.
And you can do those requests for like training jobs. You can do it for inference. You can do it for your IDE applications. Like if, for instance, you need a Jupyter Lab backed by like a P5. So yeah, you can do that for a variety of different areas. And you can also do it for like 6 hours all the way up to 6 months. So it just depends on your use case.
So I was going to ask about that, like because when the model is out, we want to try it, but we don't want to keep it the inference endpoint up for a much larger amount of time, right? So to be able to get the flexibility to have that for 6 hours and try it out and see how the organization could
Yeah.
benefit out of this inference, and maybe if that's the right model, then keep it on for much longer using the auto scaling
Yep,
policies.
exactly. And you can if for instance we have users that say, hey, my website doesn't get traffic at night, how do I manage that and, not pay as much to have the endpoint running consistently? And on an endpoint, you can scale down to 0. There will be a cold start, but you can scale that down to 0. So you're not even paying for the GPUs that you need. But you can also, for instance, if you're doing testing or there's going to be a spike, we always hear like Super Bowl weekend is a big spike. You can say, hey, I need more instances because I know it's going to auto scale up. And in which case, you can do that flexible training plan at that point as well.
So that's a great call out. And for anyone who's trying the labs today, make sure you set the auto scaling to 0 when you're done with the lab, or actually delete the endpoints, right? So
Delete
the
it.
safest way. Okay.
I would
Yeah,
just
just
do it.
delete it.
Yeah. All right. Sounds good.
All right.
So
Thank you so
thanks.
much, Anil. Yeah, it was a pleasure chatting with you and the folks here.
Yeah. You're welcome, and thanks for coming on the show. And again, we'll see you next. You see you all next week, same time, for another episode on the show and tell. Thank you all.